Hey, welcome to Graphing Quadratics in Turning Point form. Going to take you through a few screens on the calculator, and then I've got a question up here that we are going to do. Here in the calculator, whoa, there we go. Y equals x squared. There's our parabola. We've met that before, we know it. We recognise these numbers. 2 squared is 4, 1 squared is 1, 0. And so we get this down and then back up shape. What we're going to spend the next few minutes looking at is what happens when you mess with those numbers. What if I wasn't graphing x squared? What if before I squared it, I wanted to add 1 to x? What happens then? We hit enter. You'll notice that these numbers, the same numbers are on screen, but they've moved. Instead of 0 squared being 0 and 1 squared being 1, the 0's moved back to the -1, the 1's moved back to the 0, the 4 has moved back to the 1, and the 9's come in. It's the same shape, but all those points have moved backwards 1, because what you can see from the rule is we're not just graphing the x value, we're graphing the one in front. Whatever x is, add 1 and then square it. So all these points have moved 1 to the left because we're borrowing from the one in front. So by adding 1, it makes the graph move 1 in the negative direction. Whatever happens in here with the algebra, the opposite happens on the graph. It moves backwards. So that's why when we're looking for turning points, right, what was 0, 0 is now moved to -1. Whatever's in that bracket, we see the opposite on the graph. That turning point that was at 0, 0 has moved. All right, over here I've got one set up. So let's explore what happens when that number changes. It's currently set to 0. So we're not changing anything before we square it. So that's just a graph of y equals x, because there's no change in place. We know it's opposite, so I've made it take away.
Excuse me, please stay on. Students, could we have 7C to the multi-purpose room for vaccinations, please? 7C.
So if I make that number positive, we're going to be taking away a positive number. So it might be -1, and when we've got a -1 in the bracket, it should move in the positive direction. So positive number, we're taking away a positive number. So that would be x minus 3 squared. It goes 3 in a positive direction. We would have a negative number, so it would be -2. So the equation would be x plus 2 squared. We see +2, it's moved over to -2. This is called a translation. The graph is changing, it's moving around. Translation. You can also have vertical translations, which are on this graph. So here, we're not going to move left to right. We're not going to do any maths before we square our value. What we're going to do is we're going to chuck 1 on the end. And what that's going to do is it's going to take those numbers like 9 and 4 and 1 and 0 and 1 and 4 and 9, and it's going to make them a little bit bigger. So we'll square it and then add 1. So if we add 1 to all those numbers, that's now the number on the end is set to 1. What was 9 is moved up to 10, and what was 4 is moved up to 5, and 0 is moved up to 1, and 1 is moved up to 2. And it's a straight addition. The number that we add, so we got +1, it's gone up 1. So it's not the opposite. Whatever we add, it goes in that direction. We add 5, it goes up 5. We set to take 5 on the end, it goes down 5. So a little more intuitive there. So we've got vertical translations and horizontal translations. All right, there's a bit of a dance move that goes like this. Translations. We'll put it all together later. You can bust it out at the disco next weekend. So that's the translations. We also know that graphs can change in a dilation. I'll set this to just to be 1. There we go. So multiply my squared number. So whatever my number is, let's double it. Let's set this to 2. There we go. So A now equals 2. So double it, square it and double it. What was 1 is now 2. What was 4 is now up at 8. What was 9 is now 16. All these points have been moved up, which makes it look skinnier. Yeah, making it taller makes it look skinnier, like a dodgy mirror in a cheap clothing shop. If we go less than 1, down this way, so 0.2, what was 1 is now 0.2, what was 4 is now down at 0.8, and what was 9 is down at 1.8, 20%. So numbers less than 1 are going to drag all our points down and make our parabola look wider. If we make it too wide, oh, it turns itself inside out. We hit 0, there's no parabola, and then watch it, oh, wide, 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 and upside down. We get into the negative numbers, it's reflected in the axis, and same's true. The more negative, the more the points move down, the more it looks skinnier in the negative direction. So dilations, yeah, think about pupils dilating, opening, widening, and reflections upside down. You are going to have to look at all three of these at once. It could be moved left to right. That would happen if there's a change inside the bracket. You could be moved up and down. And you could be dilated and reflected. All of those things can happen. That's great, Mr. Morton, but what about how do we do the questions? Let me see if I can make this work. Here we go. You might have a question like this. It's got all three. It's got something happening in here. We've got a number on the end. It's been dilated. First, we're going to look at the translations. We're going to -1 means we're going in the positive direction by 1. So where our turning point was there, it's now going to be over here at 1. We've got a -5, which means we're going down by 5, which is taking us down here to 5. So turning point is going to be at 1,5. We get that straight out of the formula. So we've got translation. Do we have a dilation? Yes, we do. So this thing's going to be taller and skinnier, but we don't have a reflection in this situation. So we've got quite a tall, skinny parabola like that. We still should be graphing our x and y intercepts, and we do that the same way we've always done. X equals 0 and y equals 0. Make x equals 0, we get 1. 1 squared is 1. 2 times 1 is 2. Take the 5 off, it's -3. Is that number there? If we make x equals 0, y equals -3. And if you make y equals 0, there's a little bit more work required. 0 is going to equal 2, x minus 1 squared minus 5. So move the 5 over, it's going to equal 2 lots of x minus 1 squared. 5 on 2 is going to be x minus 1 squared. Then we're going to square root everything, and when you square root, you don't know if you have the positive square root or the negative square root, so now we've got 5 on 2 is what x minus 1 is, and that's good because we want two answers. It's going to be 1 plus or minus the square root of 5 on 2, which is what x will be. So this one here will be 1 minus root 5 on 2. This number is a little bit more than 1, which is why we're negative. And this is 1 plus the square root of 5 on 2. So a little bit yucky with the surds there, but nothing we can't handle. All right, just the last thing that last slide that we had with these sliders, I've set up another video that you can go and watch, which shows you how to create your own one of these, just to have a play around. Also cool for checking your answers. You know, I can so this is in my question over here. We've got a 2 out the front. We've got a -1. H is 1. Come on, move for me. There we go. H is 1, and K is take 5. And there we go. This parabola matches my parabola up here. We've got a -3, and we've got what would be 1 minus root 5 and 1 plus root 5. So that tells me that I got the answer right, which is great. Enjoy the rest of the week. Ciao.